2.13. Impacts on the environment of nuclear reactions. Nuclear reactions, especially those used in power generation and weapons development, have significant environmental consequences that occur across multiple stages of the process. These impacts are not limited to the operation of nuclear facilities, but extend from the initial extraction and processing of uranium and other radioactive materials to the long-term management of radioactive waste. The environmental effects can be grouped into three main areas: the extraction and processing of raw materials, the functioning and maintenance of nuclear power plants during operation, and the safe handling, storage, and disposal of nuclear waste, which remains hazardous for thousands of years. Each of these stages presents unique challenges related to environmental safety, pollution, radiation exposure, and long-term sustainability, making careful regulation and oversight essential. Uranium mining. Uranium mining, the primary method for obtaining fuel used in nuclear reactors, has several significant environmental impacts throughout its various stages. Both open-pit and underground mining operations result in the destruction of natural landscapes, leading to the loss of vegetation, disruption of ecosystems, and a decline in local biodiversity. These activities often require large-scale land clearing and water usage, which can also affect nearby communities and wildlife. In addition to physical habitat damage, mining processes generate large amounts of radioactive dust and waste rock, known as tailings. These tailings contain harmful substances that can contaminate the surrounding soil, rivers, and groundwater systems if not properly managed. The radioactive particles and heavy metals in tailings can remain hazardous for many years, posing long-term environmental and health risks. Another method, in situ leaching or in situ recovery, involves injecting acid or alkaline solutions into underground uranium deposits to dissolve the uranium before pumping it to the surface. While this technique reduces surface disturbance, it presents a high risk of groundwater pollution, especially if the leaching fluids migrate beyond the targeted area or if containment systems fail. Furthermore, the entire process of mining, milling, refining, and enriching uranium is highly energy-intensive. Although nuclear power plants do not produce carbon emissions during operation, the upstream processes involved in fuel preparation contribute indirectly to greenhouse gas emissions through the use of fossil fuels. Nuclear power. The operation of nuclear power plants introduces additional environmental concerns beyond those associated with mining and fuel preparation. One of the primary issues is thermal pollution, which occurs when large volumes of water are withdrawn from natural sources such as rivers, lakes, or oceans to cool the reactors. After circulating through the plant, this water is often discharged back into the environment at significantly higher temperatures. The sudden increase in water temperature can reduce oxygen levels and disrupt the balance of aquatic ecosystems, affecting fish populations, plant life, and the overall biodiversity of nearby water bodies. Prolonged exposure to warmer water can also make these ecosystems more vulnerable to invasive species and disease. Perhaps the most serious concern associated with nuclear power generation is the risk of catastrophic accidents, as tragically demonstrated by the disasters at Chernobyl, 1986, in Ukraine and Fukushima, 2011, in Japan. In both cases, reactor meltdowns led to widespread radioactive contamination of air, soil, and water, forcing the evacuation of nearby communities and causing long-lasting environmental damage. These incidents highlighted the vulnerability of nuclear facilities to both human error and natural disasters, and they raised global awareness about the potential consequences of nuclear energy when safety systems fail. Beyond the operation of power plants, the disposal and management of nuclear waste remains one of the most complex and pressing challenges in the nuclear industry. Nuclear waste is classified into three categories based on its level of radioactivity and required handling procedures: low-level waste, LLW, intermediate-level waste, ILW, and high-level waste, HLW. LLW includes items such as contaminated protective clothing, tools, and filters used during routine plant maintenance. ILW consists of reactor components and other materials that contain higher levels of radiation and often require shielding during storage and transport. The most dangerous category, HLW, primarily consists of spent nuclear fuel, which is intensely radioactive and generates heat for thousands of years.